you figure out the larger one? Like starting with 5 pi, sine of 5 pi over 2.
So you just keep going around the unit circle.
Yeah.
So here's pi on 2.
Yeah.
Here's pi on 2. So if I add another pi to that, if I add another pi, so this plus 2 pi on 2, which is the same as pi, right?
Mm-hmm.
And pi gets me halfway around.
Halfway around.
Right? So if I add pi to this, which is the same as 2 pi on 2, I'll get the 5 pi on 2.
Yeah.
That puts me in the same position. Pi on 2 and 5 pi on 2 are the same position.
Okay.
If I add another pi to that, over here, it's going to blow it by 2 pi on 2 again, 7 pi on 2.
Yeah.
And then 9 pi on 2 and 11 pi on 2.
Okay.
It's always odd pi on 2 with these positions.
Okay.
Does that make sense?
Yeah.
Describe the pattern of values. That's sometimes you negative 1 and 1, this is a set, right? How? That's what we saw in the table.
All right, number 11.
Oh, you got the answer to B, okay?
Oh wait, B? Oh.
Yeah, it's a little weird.
Oh yeah. Let's
So
go.
this is what the graph would look like on a graphing calculator. It would look like this, where it's all bunched up here.
Yeah.
Because the thing is just oscillating very quickly as you get closer to 0, and then like faster and faster between negative 1 and 1. So that's basically what this is saying right here.
Oh.
The alternation between negative 1 and negative 1 happens many times on these small intervals here. Now, although that may not be so clear to a person, I mean, you know it's alternate between 1 and negative 1 because you saw that in the table.
Yeah.
If you know it's happening many times, it's not so obvious. But if you read the other two, the function tends towards infinity near 0. That's not true. You do not see it rising towards infinity here, right? As you get closer, as x goes closer to 0, it's not rising towards infinity. It's still trapped between negative 1 and 1.
Yeah.
As every sine function is. The function sine 1 x is not defined near x equals 0. It is defined near x equals 0. It's not defined at x equals 0. So that's not exactly what you should write. So it shouldn't be. It's not so obvious. So what do you conclude about this limit now, as x heads towards 0?
Does not exist. Right?
Okay.
Oh.
Fantastic.
Yep. 11.
11. So again, you can use a graphing calculator to plot this thing.
Mm-hmm.
Estimate this particular weird limit in each case. Use your word to make a conjecture about the value of this, any non-zero values that you think it in.
Yeah.
So it's really. Oh, okay. Let's just follow what it says. Plot this thing for n equals 2 and n equals 3. So we need to put in your calculator sine 3x over sine 2x. That's what we want you to do. Plot that in your calculator, right?
Yep.
So y1 in the calculator, you're going to write sine 3x, sine 3x over sine 2x. No cancellations are possible. You're stuck with that representation.
Mm-hmm.
Okay? So when you plot that, you just want you to tell what it looks like. So write a calculator here. Plot it already.
Let's see.
I can plot it on this monster here. By the time it loads up, you have that already. Yeah, mine's not working. I'm very sad.
I think it's C.
Just look at your calculator, it looks okay.
It looks like C.
Try this one more time. I don't know why it's not working.
Yeah, I don't know.
Figure that out. Alright. Anyway, select your cell, try C. You're correct.
Yep.
Estimate that, choose the right answer below. Okay, so when x heads towards 0, well in this thing, it's a smooth curve here, right?
Yep.
Around 0 anyway. Around the 0, it's a smooth
Yep.
curve. So as x heads towards 0 from both sides, what is the curve approaching I don't know what the scale is here. I would guess it's 3/2 just for the scale.
3/2.
Yeah, does that make sense?
Yeah.
Okay. Now plot this for 5 and 2. Choose the correct graph. We're going to ask the same thing again.
Same thing again, I get.
And we're heading towards 5/2 this time.
Yep, be 5/2. So that is.
Looks like it's the first one.
Yeah.
Now I'm judging that by what I know the limit has to go to. I know the limit's going to go to 5/2.
Yeah.
But you want to make sure you have the correct picture for the calculator. It matches up properly. And as we see, again, as x tends towards 0, the function is heading towards this height here from both sides. It looks like 2.5 from the way they have the picture constructed. So 5/2.
Yep.
It's not a coincidence, as you notice, right? If sine 3x over sine 2x is heading towards 3/2, sine 5 over sine 2 is heading towards 5/2. It is an actual rule. So 5/2 it is.
Yep.
Answer how?
So same thing as it goes.
Say again?
Same thing as it goes, just like the previous exercise.
Yeah. Yeah. A little repetition for this one, yeah. So this
Yep.
one's going to head to 2/3, right?
Yep.
Yeah, exactly.
Quick question. If you do a problem, if you miss it, you can do it again.
Yeah.
That's true for the homework, not for the quizzes.
Yes.
The homeworks, yeah, you should be able to do it over again. James is perfect, right? I just did this trash. Snyder didn't gun it.
How would I approach, like, so first of all, put that 2 on pi in, one over that's just flip. I would say I would go with sine pi by 2 and sine 3 pi is 2. The thing with unit circles, should really find it. Let's just start the table.
Okay.
Carter Baker, Carter 2. Question?
It's time consuming, isn't it? It's time consuming.
Yeah, it's a.
Look at you, you're still on 2.1, man. It takes forever.
2.3.
Concepts well.
Yeah.
So it's like.
We shouldn't expect I can show every single problem on the board, though. You know what I'm saying? It's impossible to show every single example because a lot of these are very different. Yes, there's a common theme, but I'm happy to go around and answer the questions you have, but I will not be able to present every single possible example.
Yeah, I know. It's like.
Basically trying to understand each part.
Yeah.
This is time consuming.
Shoot. Number 4, 6 or something. Like an hour.
Best way to learn it is like a quick view example, and it'll give you the explanation.
That's what I'm doing, but
Yeah.
it's still really slow.
I just teach that. I got it.
I like to write all my steps.
See something? What you say?
Let's do 2.3.
2.3?
Yep.
Well, 2.3 is more like the problems I did here at the end, meaning at the end of the lecture. To help me have a little more familiar. With my brain. 2.3. Any particular one?
We'll just go through it one by one. So let's start with the first one. Alright, so we're on the same problem.
So this says use